welcome you all to Think Maths. We are in class 10 Maths, chapter 6, triangles. In this session, we are going to discuss about exercise 6.2, all the questions 1 to 10. So, first question, in figure 1 and 2, DE parallel to BC. Find EC in 1 and AD in 2. So, there are two problems in the first question. Now, we are going to see the first problem. Okay. So what is given? AD is given, DB is given, AE is given. We have to find out EC. Another hint is DE parallel to BC. So then we know by basic proportionality theorem, we know the ratio AD by DB equal to AE by EC. So AD by DB equal to AE by EC. So what is AD? Is 1.5. DB is 3. AE is 1 centimeter. We have to find EC. So let us cross multiply. So 1.5 into EC equal to 3 into 1. So EC will be equal to 3 into 1 is 3. 1.5 is in product. When we change the sign, it will be in division. So let us multiply by 10. So why we are multiplying by 10? Here the decimal point is before one number. So if it is before one number, we should have 1 0. Okay. So if it is before two numbers, you have to multiply by 1 2 zeros. 1 0 0, that is 100. So if you multiply by 10, you will get EC is equal to 3 into 10 30. 1.5 into 10, we will get 150. So if you put a decimal before 0, it is valueless. So the answer is 15. So 30 divided by 15 is 1 15s are 15, 2 15s are 30. So EC is equal to 2 centimeter. So let us see this second problem in the next page. So here also DE is parallel to BC. So if it is so, we have the ratio AD by DB equal to AE by EC. So this is by basic proportionality theorem. So what is AD? It is not given. We have to find out. What is DB? It is 7.2, which is equal to AE is 1.8. What is EC? 5.4. So we have to find AD. AD will be equal to 7.2. This is in denominator. When I change the side, it will be in numerator. 7.2 into 1.8 divided by 5.4. So if you have decimal in denominator, it is before one place, we have to multiply by 10. So if you multiply by 10, AD will be equal to, so keep the 7.2 as such, 1.8 into 10 is 18. 5.4 into 10 is 54. So 1 18s are 18, 3 18s are 54. So the answer is 7.2 divided by 3. So 1 3s are 3, 2 3s are 6, balance 1, 4 3s are 12. So the answer is 2.4 centimeter. I hope you can understand this problem. So moving on to the next problem here. E and F are points on the sides PQ and PR respectively of a triangle PQR. For each of the following cases, state whether EF parallel to QR. So they have given some values. We have to check whether this ratio PE by EQ is equal to PF by FR. So if it is so, by converse of BPT, we can say EF parallel to QR. Okay. So they gave the points. So I am going to draw a line EF parallel to QR. We have to prove this EF is parallel to QR. So for this, what we have to do? We have to prove this ratio. PE by EQ should be equal to PF by FR. Okay. So we have to prove. If we prove this, by converse, we will get EF parallel to QR. So let us take the first left hand side, PE by EQ. What is PE? It is 3.9. EQ, it is 3. So 1 3s are 3, 1 3s are 3, 3 3s are 9. So it is 1.3. What is PF by FR? PF is 3.6, FR is 2.4. So we have to multiply by 10 on numerator and denominator. We will get 36 by 24. In 12 table, we will get 2 12s are 24, 3 12s are 36. That is 3 divided by 2, which is 1.5. So now if we compare 1 and 2, we get PE by EQ is not equal. Okay, it's not equal to PF by FR. So if this is not equal, then by converse, EF is not parallel to QR. Okay, so this is by converse of BPT. I hope you can understand this. So moving on to the second half in the next page. So what is here? Here P is equal to 4 centimeter, Q is equal to 4.5 centimeter, PF is 8, RF is 9 centimeter. So we have to prove EF parallel to QR. So let us take the ratio PE by EQ. So it should be equal to PF by FR. So let us take PE by EQ. What is PE? It is 4. EQ and QE are same. It is 4.5. So multiplying by 10 on up and down, we get 40 by 45. So 8 5s are 40, 9 5s are 45. So it is 8 by 9. So take the right hand side, PF by FR. What is PF? It is 8. Yeah. Here it is FR. Here it is RF. Both are same. So it is 9. So from 1 and 2 we get the ratios equal. That is PE by EQ is equal to PF by FR. So this is from 1 and 2. So if the ratio is equal, then we have EF parallel to QR by converse of BPT. Okay. So if ratio is equal, then EF will be parallel to QR. Okay. So moving on to the third one. So here PQ, PR, PE and PF are given. So let us check the ratio and we will check whether EF is parallel to QR. So first left hand side is PE by EQ. Right hand side is PF by FR. So let us check whether we are getting this. PE by EQ. What is PE? PE is 0.8. EQ is not given. Instead, they gave PQ. So, this is given. PQ is given. From this, we have to find EQ. So, this is also given. So, from PQ, if you subtract PE, you will get EQ. So, EQ is nothing but PQ minus PE. So, 0.18. What is PQ? It is 1.28. PE is 0.18. So 0.18 divided by 1.28 minus 0.18. 8 minus 8, 0. 2 minus 1, 1. 1 minus 0, 1. So it is 1.1. So you have to multiply by 10. So if you multiply by 10, you will get 1.8 divided by 11. So what is 1.8 divided by 11? So again let us multiply by 10 so that this decimal gets cancelled. So you will get 18 divided by 110. So in 2 table it is 9 2s are 18, 5 2s are 10 and 5 2s are 10. So it is 9 divided by 55. So let us check for other half. PF by FR. What is PF? PF is 0.36. FR FR is not given. Instead, they gave the PR. PR, if it is given, PF is given. FR is nothing but PR minus PF. So PR minus PF. 0.36. What is PR? PR is nothing but 2.56 minus what is PF? It is 0.36. So 0.36 divided by, if you subtract 2.56 and 0.36, 6 minus 6, 0, 5 minus 3, 2, 2.20. So, if you multiply by 100, all the decimals get cancelled. So, 36 divided by 220. So, if you multiply by 2, you will get 18. Here, 110. Again, if you divide by 2, it is 9 2s are 18. Here, 55. So, the answer is 9 divided by 55. So, this is 1 and 2. So, we got the same ratio. So, let me erase this calculation. So, from 1 and 2, we have the ratios equal. So, from 1 and 2, PE by EQ is equal to PF by FR. So, this implies EF is parallel to QR by converse of BPT. I hope you can understand. So, let us move on to the third question in the next page. What is here? If LM parallel to CB and LN parallel to CD, prove that AM by MB is equal to AN by AD. So, first let us take LM parallel to CB. So, LM is parallel to CB. This LM is parallel to CB. So, let us consider this triangle. Okay. So, A, B, C. So, in triangle ABC, if this is parallel, by basic proportionality, AM by MB is equal to AL by LC. AM by MB is equal to AL by LC by BPT. What is given? Another one, LN parallel to CD. LN parallel to CD. This LN is parallel to CD. So, let us consider this triangle A, C, D. So, in triangle A, C, D, then we have AN by ND is equal to AL by LC. AN by ND is equal to AL by LC by BPT. So, this is 1 and this is 2. If you check 1 and 2, right hand side is same. Then left hand side will be same. So, from 1 and 2, we have AM by MB will be equal to AN by ND. So, but here we have AM by AB, this full side. On the other side, we have AN by AD. So, how to get the full side? We have to add 1. Before that, this AM here it is in numerator and AN is also in numerator. So, if we add now 1 here, we will get AB by MB. So, but we need AM by MB. This AM and AN should not change. So, what I am going to do? I am reverse. Just I am writing MB by AM. Here also you have to reverse ND by AN because we need AM and AN. Okay. So, now if you add 1, MB plus AM is nothing but MB plus AM is nothing but AB. Okay. So, AB will be there. AB will be there and AM will also be there. So, next step is add 1 on both sides. Okay, so MB by AM plus 1 equal to ND by AN plus 1. So if you take AM as LCM, MB plus AM equal to, here AN is LCM, ND plus AN. So MB plus AM is nothing but AB. So AB by AM equal to ND plus AN is nothing but AD. So AD divided by AN. So now we have AM and AN as such. But AM and AN are in the numerator. So again you have to reverse. So if you reverse on both sides, the value will not change. So AM by, so I'm sorry. So if we reverse, we will get, it is correct. AM by AB equal to AN by AD. So we have proved. Okay, understood? So moving on to the next problem in the next page. Fourth question. If DE parallel to AC and DF parallel to AB, AE, prove that BF by FE is equal to BE by EC. So in the same way, we have to use basic proportionality theorem. So what is given? DE parallel to AC. So DE. So this line is parallel to AC. So let us consider the triangle ABC. Okay. So triangle ABC. So this full triangle. Okay. So in this full triangle, we have DE parallel to AC. So here they started with B. So we are going to start with B. So BD by DA will be equal to BE by EC because DE is parallel to AC. So BE by AC, EC. So in triangle ABC, we have BD by DA equal to BE by EC by BPT. So another parallel line is DF parallel to AE. So which one? This DF is parallel to AE. Okay, DF is parallel to AE. So here we are going to consider the triangle, this triangle. Okay, AEB. So in triangle AEB, what we have? In triangle AEB by basic proportionality theorem, we have BD by DA is equal to BF by FE. So we have BD by DA equal to BF by FE. Okay, so this is by BPT. So let us keep this as 1 and this is 2. So if you check 1 and 2, left hand side is equal. So automatically right hand side will be equal. So we will get from 1 and 2, we get BE by EC equal to BF by FE. So this is what we have to prove. BF by, so you can write it as BF by FE equal to BE by EC. Okay. So this is what we have to prove. We have proved it. Okay. This is a simple problem. I hope you can understand. So moving on to the next problem. What is given? That is a triangle DE parallel to OQ and DF parallel to OR. We have to show EF parallel to QR. So let us first consider DE parallel to OQ. That is DE is here and OQ is here. So these two are parallel. Okay. So let us consider this triangle. Which triangle? PQO. So in triangle PQO, what we have? PE by EQ is equal to PD by DO. PE by EQ equal to PD by DO by BPT. What is another one? DF. DF is parallel to OR. Where is DF? DF is here and this is parallel to OR. So let us consider this triangle POR. So in triangle POR, what we have? PF by FR will be equal to PD by DO. PF by FR equal to PD by DO. So this is also by BPT, basic proportionality. So let us keep this as 1 and this is 2. If you compare 1 and 2, right hand side is same. So you will get the left hand side equal. So from 1 and 2, PE by EQ will be equal to PF by FR. That is PE by EQ is equal to PF by FR. So this EF is the line dividing PQ and PR. So we have EF parallel to QR by converse. EF parallel to QR by converse of BPT. This is what we have to prove and we have proved it. Okay, understood? So let me go to the next problem. Sixth one. ABC are points on, so A, B, C are points on OP, OQ and OR respectively, such that AB is parallel to PQ and AC is parallel to PR. We have to show BC is parallel to QR. So this is same as the previous problem. So we can do it easily. So what is given? AB is parallel to PQ. So this AB is parallel to PQ. So let us consider this triangle OPQ. So in triangle OPQ by BPT we have OB by BQ equal to OA by AP. OB by BQ equal to OA by AP. So this is by basic proportionality theorem and we will keep it this as 1. Next here AC is parallel to PR. Where is AC? So AC is here and this is parallel to PR. So consider this triangle. Triangle OPR. Okay. So in triangle OPR, what do you have? So this is parallel. This AC is parallel to PR. Then OC by CR equal to OA by AP. So OC by CR equal to OA by AP. So if you check 1 and 2, so I keep this as 2. So if you check 1 and 2, right hand side is same, OA by AP. Then we have left hand side equal. So from 1 and 2, we have OB by BQ equal to OC by CR. Where is this? OB by BQ equal to OC by CR. So this BC divides OQ and OR. Then we have BC parallel to QR by converse. So we have BC parallel to QR by converse of BPT. Okay children, can you understand? So moving on to the next problem. Seventh one. Using theorem 6.1, prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Okay. So here in triangle we have three sides. So let us keep this as A, B, C. So prove that a line drawn through the midpoint of one side. So let us keep this as one side. So this is 1, 2, 3. So there are three sides. One side, from this side I am going to take the midpoint as D. So midpoint of one side of a triangle parallel to another side. So this is the another side. So it is parallel to another side. So let us keep this point as E. Bisects the third side. Okay, so if this is the second side and if this is the third side, DE parallel to another side, which is the third side, AC. So it bisects, that is AE is equal to EC. So E divides AC into two half. We have to prove AE is equal to EC. Okay, so now what all given? It is given that D is midpoint of AB. Midpoint of one side, we took it as AB. So D is midpoint of AB. Then we have AD is equal to DB. Also this DE is parallel to another side, which is BC. So DE parallel to BC. So if this is so, by basic proportionality theorem, what we have? AD by DB is equal to AE by EC. AD by DB equal to AE by EC. So from 1 we have AD is equal to DB. So instead of AD you can put DB. So DB by DB equal to AE by EC. So this is from 1. So dB by dB means it is 1. So 1 equal to AE by EC. So if you cross multiply, you will get AE equal to 1 into EC is EC. So AE is equal to EC. So these two lines AE and EC have the same length. That means E bisects AC. Okay. So bisects the third side AC. Okay. This is what we have to prove and we have proved it. So moving on to the next problem. Using theorem 6.2, that is converse. So that theorem 6.1 it is BPT. Theorem 6.2 is converse of BPT. What is that? Prove that a line drawn through the midpoints of any two sides of a triangle is parallel to the third side. Okay. So there are three sides. 1, 2, 3. So this is triangle ABC. What is given? Prove that a line drawn through the midpoints of any two sides. So let us take the sides AB and AC is parallel. So what is given? What we have to prove is parallel to the third side BC. So let us keep this midpoint as D and E. So a line drawn through the midpoint of two sides is parallel to the third side. So we have to prove DE parallel to BC. So what all given? D is midpoint of AB. So this means AD is equal to DB. Also E is midpoint of AC. So this means AE is equal to EC. Okay. So let us check the ratios. If ratios are equal, then we will have DE parallel to BC by theorem 6.2. So let us check the ratio AD by DB. So AD is equal to DB. So we will get DB by DB, which is equal to 1. In the same way, let us check for AE by EC. AE is equal to EC. So instead of AE, I am putting EC. So EC divided by EC is 1. So from this, we have both the ratios equal. So from 1 and 2, we have AD by DB equal to AE by EC. So if the ratios are equal, then we have DE parallel to BC by theorem 6.2, that is converse of BPT. Okay children, can you understand? So moving on to the next problem. So ninth problem, ABCD is a trapezium in which AB parallel to DC and its diagonals intersect each other at the point O. Show that AO by BO is equal to CO by DO. So what is given? ABCD is a trapezium in which AB is parallel to DC. So what is a trapezium? Exactly, pair of opposite sides are parallel. That is, AB will be parallel to one pair of opposite sides will be parallel. Here AB is parallel to DC. Okay. So these diagonals AC and BD intersect at O. So I am going to construct a line PO such that PO is parallel to AB as well as parallel to DC, because AB and DC are parallel. So if you draw a line parallel to AB, it will be automatically parallel to DC. Okay. So now what is given? AB parallel to DC. So we have constructed a line PO parallel to AB. So this will be parallel to DC. So this means PO is parallel to DC. Okay. So now we are going to use the basic proportionality theorem. So let us first consider PO parallel to AB. PO parallel to AB. Now consider this triangle. It is ABD. So I will draw this triangle here. This is D, A, B. So we have PO parallel to AB. So by BPT we have, so here it is given AO by BO. So let us also write BO by OD is equal to AP by PD. Okay. So by BPT we have AP by PD equal to BO by OD. Okay. So this is by basic proportionality theorem. Also we have PO parallel to DC. PO parallel to DC. So let us consider this triangle ADC. ADC. We have PO parallel to DC. So then we have AP by PD is equal to AO by OC. So by BPT, AP by PD is equal to AO by OC. So this is 2. So if you check 1 and 2, left hand side is same. So right hand side will automatically be same. So from 1 and 2, BO by OD is equal to AO by OC. So here AO and CO are in the numerator. So just we can cross multiply. That is interchange. So this OC can be written here and BO can come down. So it will become OC by OD is equal to AO by BO. So AO by BO is equal to CO by DO. So it is nothing but OC is nothing but CO. OD is nothing but DO, which is equal to AO by BO. We can write this as AO by BO is equal to CO by DO. Okay. So we have proved it. I think you can understand this problem. So moving on to the last problem. The diagonals of a quadrilateral ABCD intersect each other at the point O such that AO by BO is equal to CO by DO. Show that ABCD is a trapezium. So what is a trapezium? One of the opposite sides will be parallel. So we have to show AB is parallel to DC. So in the previous problem we constructed a line. So in the same way I am going to construct a line. We don't know AB is parallel to DC. So let us take just PO parallel to AB. Okay. So what is given? AO by BO is equal to CO by DO. What we constructed? We constructed PO parallel to AB. Okay. So if PO is parallel to AB by BPT. In triangle, which triangle? This ABD. In triangle ABD, we have AP by PD is equal to BO by OD. So AP by PD equal to BO by OD. Okay. So here what is given? AO by BO is equal to CO by DO. What we can do with this? So in this we can just interchange BO and CO. So this one what becomes? If we interchange, this CO will come down. So AO by CO will be equal to BO by DO. Okay. So here we have BO by DO. So this can also be written as AP by PD is equal to BO by OD can be written as DO. So if you compare this 2 and this 3, right hand side is same. So automatically left hand side will be same. So from 2 and 3 we have AP by PD equal to AO by CO. Where it is AP by PD is equal to AO by CO. So what we got? This A and this is P and D. AP by PD equal to AO by OC. So this is a line PO. So if this ratio is equal, then we have by converse PO parallel to DC. So this is by converse of BPT. Okay. So here what we have here, I am assuming this as capital A and this is capital B. So if capital B and A, if you compare this, PO is parallel to AB and PO is parallel to DC. That is PO is parallel to AB and this PO is also parallel to DC. So if a line is parallel to, same line is parallel to AB and DC, then we have other two lines will be parallel to each other. So that is AB will be parallel to DC. So if two lines are parallel, then we have ABCD is a trapezium. Okay, understood? If one of the opposite sides are parallel to each other, then the quadrilateral is a trapezium. So one of the opposite sides AB and DC are parallel. So we have ABCD is a trapezium. Okay. I hope you can understand all this problem. If you understand, just like, share and subscribe and hit the bell button so that you get the notification whenever I upload my videos. Thank you. Thank you for watching and thank you for your support.